Hi friends, in this video we discuss about the topic that is SuperMesh Analysis. See, when you read the SuperMesh Analysis, definitely the one question arises in your mind, that is how this is different from the normal mesh analysis. So you will get your answer if you watch this video till end. So let's start it. See here, the problem statement is we have to find out the voltage through this 5 ohm of resistor for the network given in figure using the mesh analysis. So in a question, they will not give you to use the super mesh analysis. They will write only use the mesh analysis. That we need to identify whether this example is of mesh analysis or super mesh analysis. So right now we don't know anything about the super mesh analysis. We know only the term that is of mesh analysis. So like what we have done in our earlier video, we will done the same thing of mesh analysis. We will consider this is my mesh 1, current is I1. This is my mesh 2 and the current is I2. Similarly, this is my mesh 3 and the current is I3. We know that thing only. Now see, here the current direction is what? Is a clockwise direction. This end come first. So mark here plus minus. This is the polarity of the voltage drop. If you want how to put this polarity of the voltage drop, please watch the video number 1. That is the mesh analysis part 1. Now similarly see here, this is also a clockwise direction. So in this 1 ohm resistor, the polarity is like this plus minus. Now this in a I2, see the polarity, that is plus minus plus minus. Now in a I3, there are the 3 different elements. One is a 1 ohm, another is a 5 ohm, and then the one current source. But here already the polarity is there, so no need to apply any polarity. Now there are the 2 current sources present. One is a 2 ampere, another is what? Is a 5 ampere. Now you just check this branch, okay? This branch only. I am saying the notation that is AB. Now this branch, the current is what? Is a 5 ampere is given to us. And according to our notation, see the current is what? It's a I3. And this is the part of only a single loop. And the direction is also same. So directly we can say that I3 which is equal to 5 ampere. Now here, see this 2 ampere source, here it's a part of what? It's a 2 different loop. One is the I1, another is what? It's a I2. Now here we cannot say that I1 is 2 ampere or I2 is 2 ampere because it's a part of 2 different loops. So when you have a current source that is a part of 2 different loops, at that time we have to use the method which is SuperMesh analysis. See, again I am repeating, when we have a current source that is a part of 2 different loops, at that time we have to use the method which is a SuperMesh analysis. Alright. Now, see here, this is our diagram where already we have finding R, that is I3, that equal to what? 5 ampere. Now, in a SuperMesh analysis, see this, because of this source, we are using the SuperMesh analysis. Because this source is creating some trouble when we are writing the equation using the simple mesh analysis. So in a SuperMesh analysis, just remove this branch and redraw the diagram again like this. Plus minus 10 volt, this is of 2 ohm, minus plus, then no need to do this particular branch. Then here it's a what? It's a 2 ohm, plus minus, then it's a 5 ohm, then it's a 1 ohm, like this. And here our current source 5 ampere. Now let's write the current as it is here. I1, here it's a I2 and here it's what? It's a I3. Polarity just write down as it is like this. Alright. So this is, see, the one particular loop. In that loop we don't have any current source. So we will write a what? I'm talking about this 10 volt, 2 ohm, 2 ohm, 5 ohm, 1 ohm, like this. That is a one particular loop. And already for this loop, we have the direct value of current. So write down the equation for this I1 and I2 by combining the loop, which is loop I1 and I2. Let's start from here. It's a 10. Now see, earlier in the 2 ohm resistor, what is the current? I1. So we will consider that current only. So it's a 2I1 because the polarity is changing from positive to negative. Now consider this element 2I2. But here in a 2I2, earlier the current is flowing, which is I2. So we will consider that current only, which is 2I2. Now plus minus 5 ohm. So polarity is changing from positive to negative. So we will write that voltage drop as a negative voltage drop. And yes, this 5 ohm is a part of two different loops. One is I2, another is I3. So here just write down I2 is entering from the positive terminal. I3 is entering from the negative terminal. Similarly, this positive to negative. So I am just write down, see, positive to negative minus 1. And here, see here, this is the part of two different loops, I1 and I3. I1 is entering from the positive terminal, I3 is entering from the negative terminal, and equate that with the 0. So what we get? 10 minus, see, minus 2I1 minus I1, which is equal to minus 3I1. Then here, minus 2I2 minus 5I2, which is equal to minus 7I2. Minus plus 5I3, and again a 1I3 which is plus. So which is equal to 6I3, which equal to 0. So here what we get? 10 plus 6. What is the value of I3? This is 5 ampere, which is equal to 3I1 plus 7I2. So our equation will become what? 40 plus equal to 3I1 plus 7I2. So this will become my equation number 1. Alright. Now here we have a 3 different loop. Okay. But directly we have the value of I3. That is alright. Now we have 2 different loop I1 and I2. So we require the 2 different equation if we want the current I1 and I2. This is only the one equation, and we cannot write down the equation for the I3 because directly current is there. Already we have considered this loop. So how we can get the another loop equation? So that is from here. See, this branch current is like this 2 ampere, which is in a down direction. According to our assumption, see, the current is flowing, which is I1, which is in a down direction like this, according to our assumption. Similarly, I2, which is flowing in a which direction? Up direction, like this. I2 is flowing in a up direction in this particular branch. So this current is a combination of this I1 and I2. But the direction is opposite. This says is down and this is upward. So yes, we know that when the current direction is opposite, we have to do the subtraction. So there are the 2 chances. One, we can say that I1 minus I2 which is equal to 2, or I2 minus I1 which is equal to 2. So for that you have to check this direction. 2 ampere direction is same as the I1 direction. So we can say that I1 minus I2 which is equal to 2. This will become my equation number 2. If see the both direction is same, which is down direction, for example, then you have to write down I1 plus I2 which is equal to 2. See, these are our 2 equations. Now if you remember, see, our problem statement is what? We have to find out the current through this 5 ohm of resistor. And what is the 5 ohm of resistor? Like see in this diagram here. We know that the current in a 5 ohm of resistor which is equal to I2 minus I3. And we know the value of I3, which is equal to what? 5 ampere. So if you put here I2 minus 5. So we require the value of I2 from this two equation. So we have to cancel the I1. So here the coefficient is 3. So multiply this equation with the 3. So first write down first equation as it is. 7I2 which is equal to 40. Now multiply this with the 3. What we get? 3I1 minus 3I2 which is equal to 6. Now change the sign, minus, plus, minus. So this is cancel. 10I2 which is equal to 40 minus 6. 32. Sorry, it's a 34. Here we have to do 40 minus 6. Now the value of I2 which is equal to 3.4 ampere. Now substitute this value in our above equation. So I5 ohm will become 3.4 minus 5 which is equal to minus 1.6 ampere. But see here the first current is what? It's a I2. So here direction of I2 you just check, that direction is this. If anyone can write plus 1.6 ampere, then direction will become like this, reverse of this. See again I am repeating, here we have just written first I2. So you have to consider the direction of I2. If I5 ohm, if someone say 5 minus I2, then we have to consider the direction of I3, which is in this direction, which is equal to plus 1.6. So I hope this example is clear. So if you have any doubt regarding this example or any example related to mesh analysis or any topic related to this network theory or circuits and network, then you can send me an email. My email ID is palak.vadadia@gmail.com. And if you want me to prepare any video related to like circuits and network or network theory, then please send me that question to my email ID. So thank you for watching, and please I request you to like and subscribe my channel to watch the videos related to circuits and network. Again, thank you very much for watching.